You have 30 minutes. The sirens are screaming.
You can't shoot it down. It is falling from space, traveling at Mach 23.
No pilots, no GPS, just a mechanical brain guiding a nuclear spear across the world.
This is the ICBM, the Intercontinental Ballistic Missile, the ultimate machine of the Cold War. How do you engineer a weapon that ensures the destruction of humanity? Subscribe to Method and Myth as we deconstruct the mathematics of the apocalypse. In 1945, the United States had the atomic bomb, but delivering it was a massive problem. The B-29 bombers that dropped the bombs on Japan took hours to reach their targets. In a conflict with the Soviet Union, bombers were slow. They could be intercepted by radar and jet fighters.
You needed a delivery system that was untouchable. You couldn't just fly through the atmosphere. You had to go over it. To do that, the Americans and the Soviets turned to the ruined laboratories of Nazi Germany and a man named Wernher von Braun. Von Braun had invented the V-2 rocket, the world's first long-range guided ballistic missile. It didn't have wings. It didn't glide. It was essentially a massive artillery shell with an engine. To understand the ICBM, you must understand the word ballistic. A ballistic missile is not an airplane. It is a stone thrown into the sky. Once the engine shut off, the missile is entirely at the mercy of gravity and momentum. The missile blasts out of a silo and burns its massive rocket boosters for only 3 to 5 minutes. This is the boost phase. It accelerates the weapon to over 15,000 miles per hour, pushing it completely out of the Earth's atmosphere and into the vacuum of space. In space, the engines detach. There is no air. There is no drag. The nuclear warhead simply coasts through the void in a massive parabolic arc. Because it is in space, it can cross oceans in minutes, not hours. But here is the ultimate engineering nightmare. If you throw a spear 6,000 miles, how do you make sure it hits a specific city? In the 1950s and 60s, there was no GPS. You couldn't use radio signals because the enemy could jam them. The missile had to be completely blind, deaf, and unhackable. The solution was inertial navigation, a mechanical brain that literally feels its own movement. Engineers built complex systems of spinning gyroscopes and accelerometers. A gyroscope, when spinning rapidly, wants to stay pointing in exactly the same direction, no matter how the missile turns around it. By measuring how much the missile shifted away from the perfectly stable gyroscopes, the onboard analog computer knew exactly where it was in 3D space. It didn't look at the stars or talk to the ground. It just calculated its own acceleration from the exact millisecond it left the silo. If it was off by just 1 degree during the boost phase, it would miss the target by hundreds of miles. The precision required was agonizing. But getting the bomb over the target was only half the battle. Now, the warhead had to fall back down. As the warhead re-enters the Earth's atmosphere at Mach 23, the air in front of it can't get out of the way fast enough. The air compresses, creating a shockwave that superheats the atmosphere to over 10,000 degrees Fahrenheit, hotter than the surface of the sun. The nose cone should instantly melt, destroying the bomb before it detonates. Early engineers tried using heavy, heat-resistant metals, but they were too heavy to fly. The solution was totally counterintuitive: ablative shielding. Instead of trying to stop the heat, they designed the shield to burn. They coated the warhead in a layer of specialized resins and carbon composites. As the extreme heat hits the shield, the outer layer deliberately burns, chars, and vaporizes. This phase change absorbs the heat and carries it away in the wind, leaving the inner nuclear core perfectly cool. They built a machine that survived by destroying itself. By the 1970s, the terror escalated. If one missile carried one bomb, the enemy could build an anti-ballistic missile to intercept it. So engineers invented MIRVs, multiple independently targetable re-entry vehicles. One ICBM no longer carried one bomb. It carried up to 10 separate warheads, plus dozens of fake decoys. The single missile would reach space, open up, and release its warheads to strike 10 different cities simultaneously. It was a hydra. You couldn't shoot it down. The ICBM created a paradox. Because the weapons were so fast, so precise, and completely unstoppable, neither side could ever launch one. To fire an ICBM was to guarantee your own death 30 minutes later. This was the brutal mathematics of mutually assured destruction.
The very machines engineered to end the world became the absolute reason we haven't fought a world war since 1945. And ironically, the exact same guidance systems and rocket physics that threatened humanity are what took us to the moon.
The Cold War was fought in the shadows, not just with rockets, but with information. Next time on Method and Myth, we deconstruct the silent, invisible assassins of the deep, the nuclear attack submarine.